Hello Legacy students, Marsh here. So this video is on the math class. Now, you might have noticed in our arithmetic talk that there was no exponentiation available. Can't do powers. That is what we're going to talk about today, and other options as well. First, let's talk about errors, different kind of errors that you might see in programming. There are three kinds that we get to see. There's one called syntax, one called runtime, and one called logical. Syntax occurs when you violate the syntax rules. Using system.out.println, so notice I'm changing which ones are capitalized. That would be a syntax error. So you're writing something that Java does not understand. This would be stuff that is caught by your compiler. So when you try to run your program, it's going to cause an error. It's going to say, I can't run. Runtime errors occur when you ask a computer to do something it legally cannot do. So like dividing by 0. Index out of bounds error with strings. That would be another runtime error. Those are ones that the computer is going to halt in the middle of a program because you can't accomplish that task. Logic errors occur when you fail to express yourself accurately, i.e. you're using greater than instead of less than, or something along those lines. So logic errors are the hardest ones to find because those look right to you. You wrote that code. So the problem is the computer is doing exactly what you told it. And if you don't tell the computer correctly what you want it to do, it's still going to do what it thought you wanted it to do. Syntax are the easiest to find because that's your compiler. Runtime, when you're testing your program, you will see it happen. So the one that really is the hardest to work on is logic errors. Now, let's talk about those math class methods. When using the math class methods, you need to first put the word math and then put a period and then your method. So I'm going to put the word math in capital M dot abs and then -2.3. It has a bunch of methods. I'm not going to go through all of them, but only the ones you're probably going to use /C in this class, or the ones that are the most useful. First one is the absolute value method. So it's going to be capital M math.abs, ABS, and then you have two options. You can either use one with int x or a double. So this is going to return the absolute value of that value. So let's say that someone types in a negative number and you want to get the positive version. That would allow you to do absolute value. So this is always going to return the positive value of x. Okay? Exponentiation. There is not an easy exponentiation in Java. It's kind of old, so we kind of have to have a hack to do it. So we're going to use the math.pow function. Double B, double E, so you have to give it two doubles. What it's going to do is return b raised to the e exponent. So if I go math.pow 2.0 comma 3.0, what it will do is it will take 2 to the third and it will spit back out 8 for me. So keep that in mind, that is optional for you if you want to exponentiate. Now you could have just taken 2 times 2 times 2, and that would not require the math class. But keep in mind, it's kind of nice sometimes when you want to use exponentiation, especially if let's say you wanted to do to the half power or to the 1/3 if you want to cube roots. The next function is the square root function. So I got math.sqrt and then double x. It's going to return the square root of x, just like you would hope it would. So I can go capital M math.sqrt and then I'll type, let's say 9.0, and it's going to have to square root that 9. It would return, I believe, the double 3.0. So keep in mind though, notice this has to be a double to place in there. Now let's say you have an int that you typed in. You could typecast that integer variable. Okay, so keep that in mind that that's available. Just because it requires a double doesn't mean you can't trick Java into believing you have a double in there. The next one is ceiling. Math.ceil, and that also requires a double. This is going to return the next highest whole number from x. So let's say I go capital math math.ceil, and I put 3.6. Okay. That's going to give me the next whole number to that. So that would be 4. Also, this would do, if I go math.ceiling, and I had 3.2, that would also return 4. So it's always going to give you the next number up. That would be very helpful if you want to make sure there's extra of a value instead of less. It wouldn't round down. The other side of this would be floor. So I could go math.floor, and it would be 3.2. That would give me 3. So it's the next lowest whole number from x. So ceiling and floor are kind of opposites of one another. Then I got math.min. This is going to be super useful in the regards you can have a smaller of a and b. So it's going to basically do the if statement for you. So I could say math.min 3.5 comma 5.5, and it would return the minimum of 3.5 for me. There's also a maximum, so I can go math.max. That would give you the larger of the two values. Now, you could also, if you wanted, you could put in here math.max and 2 things in there. So you could ultimately compare, well, 1, 2, 3, 4 different values if you wanted to, and that could keep on growing. So keep in mind that you can always put these functions inside of one another as well. There is also the math.round function. So this allows you to round to the nearest whole number. Notice there's an int in front, so you can cut off that decimal portion. So math.round will return a decimal with that 0.0 on it. So this is going to follow your normal rounding rules that you've learned in math class. So if it's a 5 or above, it'll round up. If it's going to round down, it would be below 5. So math.round allows us to accomplish that task. So here's a couple of examples of my math class methods. Math.abs gives me 7. Math.pow 3.0, 2.0, I get 9.0. Math.pow 16.0, 0.25 gives me 2.0. Math.max gives me 40. Min gives me 20. Round gives me 4. Ceiling gives me 6. And floor will give me 5. So that allows me to kind of show you guys the different examples that you might get on that information. Now, a lot of times we want this math random number generator. This is the formula for it. And this formula is going to need to be memorized. Now, this one is going to create a random number, but not an integer. If you want that integer, you have to use the math.round and then also the int function. However, this one's kind of harder to memorize, a little bit more. So we like to typecast the formula with a +1 to int. So I use this formula right here. This is the one that I would get committed to your memory so you guys can remember certain things, okay? This is very common. It's a lot of times we want to be able to make a random number, and it's kind of interesting how this works, and I'll explain here on the next slide as we make it. So let's say I wanted to round a number between 5 and 90. My formula would look like this. Int math.random times 90 minus 5 plus 1 plus 5. Notice, high number minus low plus 1 plus low. Here's what's actually happening in this formula so you can kind of understand the math behind it. Math.random will generate a number between 0 and 1, but not including 1. Okay, so 0.90 to 0.9999999, not getting up to 1. What this is going to do is it's going to make the highest number be, well, 86, right? So that's the highest number that it wants. So that will give me numbers between 0 and 86, but not including 86, right? If I add 5 to that, it's going to give me numbers between 5 and 91, but not including 91. If I int this information, we're going to get numbers between 5 and 90. So that's actually how it works. This gives it so that you can bump up to the high number, and then this bumps up even further to get to the low. The int is what we need because we need to be able to get up to the next number. This +1 bumps it so you can get up to the high value that you want. So this formula right here, math.random times high minus low plus 1 plus low, that's the thing you need to commit to memory to be able to create a random number that we want to be able to make. That's the end of this video. We'll do a couple of programs that deal with random numbers throughout the year, and we'll pull it out. I'll try to make sure we can get that committed to memory. But until then, I will see you later, Sabers.